everybody, this is a video on integration by parts, the second of the 3 more advanced techniques for doing antiderivatives of difficult integrals. So we just did U sub, that's for undoing the chain rule. So you do not want to mix up what we're doing now with U sub. U sub is chain rule, that's whenever you have an expression and a form of its derivative in the integrand. So an example of U sub would be this one right here. You could call U x cubed plus 2, and then du would be 3x squared dx, and that is a form of what is here. So that's the old stuff. Now we're moving on to the new stuff. So integration by parts undoes the product rule. So I mentioned that a couple times, but make sure you write this down so you remember. And the thing about U sub is it's one of the most powerful techniques of integration that you're going to learn, or that's even ever been invented. It makes difficult integrals much easier, even more so than U substitution. Now, you're going to use integration by parts whenever you have 2 functions multiplied together as the integrand of the integral, because that would result in a very difficult integrand to deal with. Remember, the integrand is this stuff right here, whatever is in the integral right there. Now let's actually derive the formula. So we haven't done a little proof in a while. This is a pretty quick one. Let's say I have 2 functions multiplied together, u and v. Now remember, integration by parts undoes the product rule. So let's actually find the derivative of u times v. That's what d here is for. The derivative of u times v would be u times the derivative of v plus v times the derivative of u. Let's take the integral of each side. The integral and the derivative end up canceling because they're inverse operations, so I have uv left over. And then let's do the property of integrals that says if you have the integral of 2 things added, then I can do the integral of each one separately. Our goal is to isolate what I highlighted in yellow. So I'm just going to subtract this, move it to that side. So I have integral of u dv equals uv minus the integral of v du. This right here is the formula you're going to use. Like, this is the product rule. So your goal is to take what you start with, and it's going to be in this form right here. So you're going to have 2 functions multiplied together. You're going to call one of your functions u and one of your functions dv. And you're going to turn it into u times v minus the integral of v du. So this integral here is what you're turning this into, along with the u times v. And this integral here should be way easier to do the antiderivative of than this one that you started with. That's the whole goal of integration by parts, to rewrite a difficult integral in terms of another easier integral. Okay, so make sure you have all these notes down, pause as needed. Integration by parts, you're going to always have to pick a u and a dv term. Just like with u sub, you had to pick out u and the du parts. You're going to have to pick out u and dv, and that's sometimes a little tricky for people until you get the hang of it. There's a couple guidelines. Some people say you always make u be the thing such that when you do the derivative of it, it's simpler. Like if you make u something and the derivative of that something is more complicated than what you started with, that's a bad choice for you. This is one of my favorite things here. It's a guideline for picking u. I use this all the time. This list here, write down, you want to follow this list in order. So basically it means if you have a logarithm in your integrand, that would be u. If you don't have a logarithm, but you have an inverse trig, that would be u. If you don't have either of these 2, but there's some kind of polynomial, that could be x, something x squared, something x cubed, etc. Make that u. Keep going in order. If you don't have any of these 4, but there's something with a trig function, that would be u. So this list here tells you how you should pick u, and then whatever's left over, you make that dv. So we're going to write this over and over, this formula, so you get it in your head. You obviously have to have that memorized. They're not going to give that to you, and I won't be giving that to you either. Let's start off with a very popular integration by parts example. You see this in pretty much every book that you do as one of the intro level problems. I have the integral of x cosine x. Now you cannot do this one in your head, and you also can't do u substitution, because no matter what you would pick u to be, a form of its derivative wouldn't take care of everything else. So we're going to have to do integration by parts. Notice I have 2 functions multiplied together. So I rewrote my formula here. Now what I start with, the key that you remember is Now what you start with is u dv. Okay, so either the yellow or the blue has to be u, and either the yellow or the blue has to be dv. However you label it, u and dv have to take care of everything. So let's look at Lipet or Lippe, whatever. I don't have a log. Nope. I don't have an inverse trig. Nope. But I have a polynomial. I mean, x is a first degree polynomial. So let's make u be x. And then the stuff that's left over is cosine x dx. So what you always want to do when you do integration by parts is set up this little box, because for the formula, not only do I need u and dv here, but I also need v and du. So if I start with u being x, du, the derivative of u, is 1 dx. If I made the derivative of v be cosine x dx, then v would be the antiderivative, which is sine x. Once you have that, then you kind of just plug into the formula and go with it. So I need u times v, so x times sine x, minus the integral of v sine of x du dx. Now this is the magic of integration by parts. I started with the ugly integral. I don't know how to do that. I rewrote it as just two functions multiplied together. You don't have to do anything with this. It just stays how it is. Minus a way simpler integral. I know how to do the integral of sine. The antiderivative of sine is negative cosine. So minus a negative cosine would be plus cosine x. Don't forget that plus c. And that's actually it right there. This one isn't too bad. They're obviously going to get a little more complicated than this. But again, once you have u and dv picked out, you plug right into your formula, do one more integral. Now, if this integral is still impossible to do, it either means you did it wrong or there's more work to do. So we'll do an example of that. Now, let's check our answer so that you can see why this really is undoing the product rule. Let's do the derivative of x sine of x plus cosine x plus c and make sure that we end up with that. So if I do the derivative of this, let's do product rule first here. Derivative of first times the derivative of second plus the derivative of first times second, and then plus derivative of cosine, which is negative sine. Derivative of a constant is 0. Sine x plus negative sine x cancels, and I'm left with x cosine x. Hooray! That's what I started with. So you can see how integration by parts is undoing the product rule. All right, let's do a couple more examples. Oh, all right. So I picked u and dv, and what's probably going to happen at least once to you is you're going to pick them incorrectly and you're going to mix them up. So let me show you what's going to happen. It's going to be very obvious right away because you're going to end up with something ugly. So let me just show you so you can see at once what's going to happen. Let's say instead of letting u be x, you make cosine be the u. So then x dx is your dv. So if I need du, that would be the derivative of cosine, which is negative sine. And then to finish my little chart here, if dv is x, the derivative of v, then v would be the antiderivative, which is x squared over 2. Once I do the antiderivative, I don't do dx anymore. So that's why I'm not writing this thing anymore. So I'm going to rewrite my original integral, which is the u dv, as u times v, so cosine of x, times x squared over 2, minus the integral of v du. So then I will put a negative sign there. That would end up making that a positive. Oh my god. Okay. One thing I realized I forgot is when I made u cosine, du would be negative sine x dx. Sorry about that. So then in this here, I put my v, which is right there, and my du, which is this right here. Now look at this. This is so ugly. It's not even any easier than what I started with. If anything, I made it worse. So this is bad. I did not make my integral any easier. I made it worse. So that's how you know you have to switch your u and your dv. So let's do a couple more examples, basically however much time we have left here. All right, example 2, I have x times e to the x. It's very common to see an exponential in a u sub problem, and I'm going to write my Lipet, however you want to say it. So let's look here. Do I have a Logarithmic term? No. Do I have an inverse trig? No. Do I have some kind of polynomial? Yes, I do, because x is a first degree polynomial. So that means e to the x dx is my derivative of v. So that means the derivative of u would be 1 dx. If the derivative of v is e to the x dx, then regular old v would just be e to the x, because the antiderivative of e to the x is e to the x. So I'm going to take my original, which was this, so u and dv, and I'm going to rewrite it as u times v minus the integral of v du. Look how nice that is. This is a much more cooperative integral to take. So I have x e to the x. Now, no one really cares about this thing here. This could be the most complicated thing in the world. It really doesn't matter, the uv, because you don't have to do an antiderivative of it. What matters is that v times du is a cooperative integrand. So you should always look at your v and your du, multiply them, and decide, can I do the antiderivative of that? Now, the antiderivative of e to the x dx is just e to the x. Don't forget your plus c. Now, if you were to do, so that's what this equals. If you were to do the derivative of this, you would end up with that right there. All right, try the next one here. So I have x squared cosine x dx. So I'm going to look at my Lipet. No logs, no inverse trig. I do have a polynomial term though. So I'm going to make u, remember this tells you how to choose u. So I'm going to make u be x squared, right there. So that's my yellow. And then what's left over is my blue. That's going to be my du. So du is cosine x dx. All right, so du would be 2x dx. The antiderivative of this would be negative, oops, no, not negative. It would just be, go away, sine of x dx. Sorry, just sine of x, oh my god. So now that I have my little chart all filled out, let's just plug right into my formula. So I started with u dv. I'm going to rewrite, so I'm going to write u times v, so x squared times sine of x, minus the integral of v, sine of x, du, which is 2x dx. Alright, so let's clean this up. I have x squared sine of x minus, I'm going to pull this constant out, the 2. Then I have the integral of x times sine of x dx. This here does not mean sine of x squared. It's sine of x times the 2x is completely separate. That's why I'm putting the x here out front, so I'm not tempted to make it sine of x squared. Alright, so we have a little bit of a problem here because this is fine, like who cares about that? That's just good to go. I still can't do the antiderivative of that. So it's not that we did it wrong, it's that we have to do integration by parts again. Oh no! We'll do it quick. Now the AP exam is going to have some where you have to do it twice. They will never have one where you have to do it 3 times. Those do exist, but they're not going to ask that on the exam. So let's make this be our u, and let's make this here be our dv. So at this point, for the sake of time, I just set up this integration by part already. So follow along. Don't just copy this down blindly. Listen as I go. I need to do integration by parts again with this thing here. So I let x be u because that's my polynomial. I've just followed along with Lipet. I didn't have either of these. I had that polynomial term. I let dv be sine x dx. And I took my original. This is just coming along for the ride the whole time. It's not changing. This whole thing here is this. I do integration by parts all over again. So I have my u times my v minus the integral of v du. And then I distribute my negative 2. So negative 2 times x times negative cosine x becomes positive 2x cosine x. Negative 2 times negative, negative. So negative, negative is positive, but it's still minus that. Then I just do the antiderivative of cosine, and I get sine, and here's the final answer. Last thing I want you to write down real quick is this. We're going to practice this in class. If I have a definite integral, the formula is the exact same. It's just we have our limits of integration, and we'll practice that. All right, so I'll see you in class.